Do you have any doubt?
No, sir.
Okay. Okay, we were here. So basically, you have seen that we were studying concentration of ore, and here you can see metals of high reactivity will be
Yes, sir.
refined with the help of electrolysis, the process, and it will be converted into pure metal. And the metals of low reactivity, generally it exists in sulfide ores. So first of all, we will let it go through roasting, and then we will get metal, and then we will refine, then we will get the pure metal. What about this metals of medium reactivity? It has two parts. Basically, if this medium reactivity metal, activity metal, is in form of carbonate ore, or if it is in the form of sulfide ore. So if it is in carbonate ore, we will let it go through calcination, and if it is in form of sulfide ore, we will let it go through roasting. We will see what is roasting and what is calcination. After this process, then we will do oxidation of metal, and then when you are going to do calcination or roasting, it will be oxidized. There will be metal oxide. Then we will do a reduction of metal with suitable reducing agent, reduction of metal, and then you will get, then you are going to do purification of metal, and you will get your original metal, pure metal. Please write it. Let me know when you are done.
No, sir.
So you have seen what is mineral and what is ore. First, I'm going to write a point which is very important. Every ore mineral, but every mineral is not an every mineral. Am I audible?
Yes, sir.
Okay, sorry. So what I was saying is that every ore is a mineral, but every mineral is not an ore. As I told you, ore is only that which from which you can extract metal conveniently and profitably. But mineral is something that in which low percentage of metals are also present. But that is not called ore. Are you getting my point? If you are going to extract metal and you only extract 5%, that is only mineral. And if you are going to extract metal from from earth's crust, and if it is in heavy amount, more amount, and you can extract profitably and conveniently, that is only called ore. Okay, got it? Azan.
Yes.
Okay, now we are going to do extraction of metals low in activity series. Extraction of metals low in activity series. Activity series. That means generally they are present at the bottom of the activity series. So see how we are going to extract. First, we are going to oxidize it. Generally, they are unreactive. So I'm going to write metals low in the activity series. In the activity series are very, very unreactive. Unreactive. And if it will be oxidized or if it will react with something, we just need to, generally they exist in sulfide ore, we just need to heat in the presence of oxygen and you will get oxide of that metal. Then again, we are going to heat it and we will get our metal. So I can write the oxides of these metals can be reduced to metal by heating on, by heating only. Like the oxides of we can take example of cinnabar. Cinnabar. That is HGS. Is an ore of mercury. Is an ore of mercury. Generally, they exist in sulfide form. Cinnabar, ore of mercury. When it is heated in the air, it will be oxidized, and then we will heat it again. The oxide will be heating again. We will get pure metal. Please write it. They will be reduced on further heat. Are you done with this?
No, sir. One more.
Okay, take your time, no problem.
Yeah, sir.
Done.
Yes, sir.
Very good. Now I'm going to give you the example. This is Cinnabar HGS. So you can see what happens here. We are going to take 2 HGS, 2 mole of HGS in solid state and heating in the presence of oxygen, gaseous state. First, it will be converted into oxide. That means 2HGO in solid state, and then 2SO2 will be evolved gas. Then again, this oxide, metal oxide, will be heated and it will be reduced to mercury 2Hg, which is in liquid state, plus SO2 plus O2 gases. Similarly, we can do for copper sulfide. Similarly, we can do for copper sulfide. You can see if you have 2Cu2SO4 S, this is in solid state, and you are going to react this with oxygen, that is 3O2 in gaseous state. It will give you 2Cu2O, oxides of copper, and SO2 will be evolved. Again, this metal oxide will be reduced with this Cu2s, and you will get, and if you are going to heat it, you will get copper. Copper oxide will be reduced, and then this. So you can see you just refined or got the matter. This is how we extract metals which is very low in activity series. Is it done? Are you done with this, Azaan?
Yes.
Okay. It wasn't extracting metals in the middle of activity series, in the middle of the activity series. So medium reactivity is used, that is type of that is carbon and Azaan, am I audible?
Yes, sir.
So see, middle of the activity series, basically moderately reactive. They are moderately reactive, moderately reactive. And if you are going to take an example of this moderately reactive elements, the examples are they are generally iron, such as iron, zinc, lead, etc. And generally they found in sulfide and carbonates. Generally, or we can write these are generally present as sulfides or carbonates. These are generally present as sulfide and or carbonates in nature. So both have different method to purify. First of all, basically these sulfide ores will be, you can see, this sulfide ore will be carrying through roasting and carbonate is through calcination. And what is this carbonate? Basically, sorry, what is this calcination and roasting? We are going to discuss. So first of all, I'm going to discuss about this roasting. So I'm going to write about roasting. It's very simple. So I'm going to define it. The sulfide ores, and roasting is only for sulfide ores. The sulfide ores are converted into oxides by heating strongly, by heating strongly in presence of excess air, in the presence of excess air. Both have the same thing to do. We just need to convert sulfide ores into oxide, and in carbonate ore that will be also into oxide, converted into oxides. Both have the same way. We just need to both have to do the same way, like sulfide ores into oxide and carbonates ore into oxide. Only the difference is sulfide ores will go through roasting. And what is roasting? The conversion of sulfide ores into oxides by heating strongly in the presence of excess air. This process is known as roasting. This process is known as roast. Please do write it. Then I will go for calcination. Basically, calcination is in limited air, you can say, or roasting is in excess of air, excessive air. So it's very easy to understand. Roasting is heating the sulfide ores in presence of excess air, excessive air, and calcination is heating of carbonate ores to convert into oxides in limited air. This is the difference. Let me know when you are done with it. Let me know when you are done with this.
Done, sir.
Very good. So now I'm going to take example of this roasting. So you can see basically this ZNS zinc sulfide. Whenever there is sulfide of middle reactivity, what you need to do is react heat in the presence of excessive air. So you will get Zn and SO2 will be evolved. Are you getting my point? And after this, what you need to do, if it is converted into oxide, you just need to heat it again and then, middle reactivity series, middle activity elements. This ZNO will be reacting with some suitable reducing agent, and here we only use in this class carbon. Carbon will take oxygen from zinc oxide, and now it will be zinc, and this will be carbon monoxide. This is very easy. Yes or no? So you can see sulfide ores of low reactivity series, you just need to heat twice. And in medium reactivity, you just need to, if it is sulfide ores, you need to heat in excess of air and you will get metal oxide, and then use a suitable reducing agent like carbon and you will get your metal. But if it is carbonate ore, we will do calcination, that is conversion of carbonate into oxide in limited presence of air, that is called calcination. You will get metal oxide, and then again that metal oxide will be reduced with suitable reducing agent like carbon and you will get your metal. Please do write it and let me know. Are you done with this?
Yes.
Okay. Now we are going to talk about calcination. Let's see what is calcination. So basically, in the above, it was the sulfide ores, and here it is the carbonate ores. The carbonate ores are converted into oxides by heating strongly in limited air. This process is known as calcination. This process is known as calcination. Also, you can take example like if you have zinc is existing ZnCO3, you just need to heat it in the presence of limited air and you will get oxide of zinc. And then again, you are going to use suitable reducing agent like this, carbon, and you will get your metal zinc in solid and carbon dioxide, carbon monoxide. Please do write. Also, we always don't use carbon coke. This is also known as carbon coke. Sometimes we use coke. We can use other metals which will show displacement rates. We will talk about this. First write it and let me know when you are done. Are you done with this?
Yes, sir.
Now see, we usually use this, but there can be displacement reaction also. So I can write besides using carbon, besides using carbon, and this point is very important that in scope to reduce metal oxide, metal oxides to metals. Sometimes we also use, or we can write wait a minute. Besides using carbon to reduce metal oxides to metals, sometimes displacement reaction can also be used. Can also be used because you know that more reactive element can replace less reactive element, and this will be applying only to the highly reactive element. The highly active or reactive metals, as we know that sodium, Na, that is stand for sodium, potassium, calcium, aluminium, etc. can be used to or reduce or can be used as a reducing agent or can be used as reducing agent. This is very important because they can easily replace. They are more reactive. That's why, because they can displace metals of lower reactivity from their compounds. So it's very easy to understand. If you are going to react more reactive metal in a compound where less reactive metal is present, more reactive metal can easily displace that less reactive metals, and that reaction is known as displacement reaction. You have already studied this in first chapter. Please write it. And there will be an important reaction that used to join railway track, because in this reaction there will be evolution or evolution of a lot of energy, heat energy. Please do this and let me know when you are done with this. Azaan,
Yes, sir.
okay, please let me know when you are done with this. Then I will take example and explain again.
No.
Very good. Now see, I'm going to take an example. So see, example is basically this is manganese dioxide reacting with aluminum, which is very reactive. Then what aluminum will do? Aluminum is since more reactive, so manganese will be replaced by aluminum, and we will get 3Mn in liquid state. Since it is matter and still we are getting it in liquid state because the reaction is highly exothermic. You know what is exothermic reaction? Yes or no? This displacement reaction are very or highly exothermic reactions are highly exothermic. It will evolve a lot of heat energy that will convert manganese, a metal which should be in solid, in liquid state. Is that clear? Is that clear?
Yes, sir.
I'm sorry, I was just I was got disconnected. Am I audible clearly?
Yes, sir.
Are you done with this?
Yes, sir.
Now see, as I told you, this reaction is usually used in joint railway track. So I'm going to write a point which is very important. The reaction, please write with me, of iron 3 oxide, that is Fe2O3, with aluminium. is used to join railway tracks. Used to join railway tracks for cracked machine or cracked machine. This reaction is known as thermite reaction. Might react because it evolved a lot of heat energy that will convert that cracked part into molten state and then help to join the railway tracks or cracked machine parts. So this is Fe2O3. I'm going to write the reaction plus 2Al in solid state. You will get 2Fe in molten state and then Al2O3. Since aluminum is more reactive than iron, that's why it just displays it. Please write this. Are you done with this?
Yes, sir.
Azaan, I'm going to give you homework. You are going to do question. Do you have NCERT book? Azaan, do you have NCERT book?
Yes, sir.
So you are going to do question number 1 to 7 only. Okay, I will check it in the next class.
Okay, sir.
Okay, thank you so much. In the next class, we are going to